Okay, maybe we can discuss it next hour. Okay, shall we just still offer streaming? Yeah, maybe we. But how about recording? Doing is okay, ma? Recording is okay. Is the lecture being recorded? Okay, 好. All right. So we can discuss that. But anyway, linear and time invariant, two properties. So then you can, just as a kind of brain teaser, 想要动动脑筋的话，脑筋急转弯一下. It's a brain teaser. You may be able to find example of a system that's linear but not time invariant, or the other way around, nonlinear but time invariant. Okay, yeah. So there are examples for sure, and I'll leave that as an exercise to be discussed this Thursday. By the way, that's one of the questions, right? But anyway, last time we also mentioned the important property that an LTI system is characterized by its impulse response, in that when we receive an input and the impulse response is defined. Okay, it's defined. The impulse response is defined as the system's response to delta function. That is when we use delta function as input, right? And the system produces an output. That output is called the impulse response. Okay, that's simply a definition. And we have shown that if a system is LTI, then the output equals to the convolution of the input with the impulse response. Y equals to x convolve with h. Okay? And this is a good old definition of convolution. And last time, although this is quite easy to remember, in time domain convolution and in frequency domain we see later because of convolution theorem, the consequence, important consequence, is that in frequency response, in the frequency domain, we have multiplication of two spectrums. Okay, the two spectrums multiply. But then here, last time, I wanted to emphasize that